In this section, we are going to look at derivatives of trigonometric functions. So for starters, we are going to examine the sine function. And if you recall from pre-cal 12a, the curve f of x equals sine x would look like the following. Okay, I have my x values and my f of x values. Down here, I'll use, my x values will be measured in radians. So I'll go with 0 radians, pi over 2 radians, 1 pi radian, 3 pi over 2, and 2 pi. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. When I scroll down, you will see this curve. So I will plot these points. 0, 0, pi over 2, comma 1, 1 pi, comma 0, 3 pi over 2, comma -1, and 2 pi, comma 0. So we can assume this is 1, and this would be -1. And I join those with a nice smooth curve, just like we did in Chapter 5 of Pre-Calculus 12a. And there is your curve. Now, if I want to sketch the curve of the derivative, all right, recall that the derivative f prime x, using Newton notation, of a function f of x gives the slope of the tangent line. Now, you will notice that in this diagram, there is a tangent line drawn right here. There is a tangent line drawn here, and here, and here, and here. Now, if I asked you the slope of this line, or the slope of this line, I think we can all agree that the slope of a horizontal line is equal to 0. So therefore, f prime x, the tangent line, would have a slope of 0. Same thing here. How do I know that? Because this line is horizontal. Now you might ask, or through a similar process, be able to determine that the slope of this line, it's positive, it's rising from left to right, and it looks like it's going up 1 block, over 1, up 1, over. The slope of that line is 1. Same thing here at 2 pi. The slope of the tangent, or the derivative, would be positive 1. Well, if that's 0, horizontal, that's 0, horizontal, rising left to right, positive 1, rising left to right, positive 1, what do we suppose that this would be? The derivative here would equal, well, if you notice, it's falling from left to right. It's down 1, right 1. So this would have a slope of -1. Now I can use that information, okay, to draw the derivative. Okay, so I am going to say here is a table for the derivative. And x and f prime x is going to look like the following. So I'll still use the same x values, 0, pi over 2, 1 pi, 3 pi over 2, and 2 pi. Now, let's see. What was the derivative equal to when x was 0? Well, here's where x equals 0, and I said the slope of that line was 1. When x is pi over 2, what's the slope of the tangent? Not the y value, not 1, but rather what's the slope of that tangent line right there? We said it was 0. Okay, at pi it was equal to -1. At 3 pi over 2 it was back to 0. And at 2 pi it was back to positive 1. Now watch this when I plot those points. 0 radians, comma 1, pi over 2 radians, 0, 1 pi radian, we are at -1, 3 pi over 2, 0, and 2 pi, comma 1. Now notice, on this curve, we have our x-axis and our y-axis. But on this curve, we've got our x-axis, and we're actually sketching the height, sorry, not the height of the function, rather the derivative, f prime x. So that's a huge thing to note. Now, there's the curve y equals sine x, or f of x equals sine x. When I join these with a smooth curve, that's not real smooth, but it's not so bad for my tablet work here. What shape does that curve actually have? If you said f prime x equals cosine x, all right, that makes a cosine. So if f of x is equal to sine x, f prime x, its derivative, is equal to cosine x. You can also see here, check this through the definition of a derivative. Okay, so let f prime x equal the limit as h approaches 0 of f at x plus h minus f at x all over h. So we write sine x plus h minus sine x over h. Remember, if f of x equals sine x, f at x plus h is going to equal sine x plus h. And this is really just a sum identity that we learned in Pre-Cal 12a as well. So I can replace this thing right here with the following. Sine x cos h plus cos x sine h. The minus sine x, it didn't change. It's still right here. And then we reorganize it a little bit. Okay. I wrote sine x cos h minus sine x over h. And I kind of separated this into a separate term, cos x times sine h over h. And that's a legal move. As long as the denominator is the same, you could add the numerators and it would bring you back here. You might ask, well, why did you do that? Reason being is because from here to here, look at both of these terms have a sine x. All right, so if I factor this out, if I divide the numerator by sine x, this term in the numerator by sine x, it would leave cos h. If I divide negative sine x by positive sine x, I'm left with negative 1, okay, over h. Same thing here. I'll take a cosine x out, and it leaves sine h over h. And then I can reorganize through my property of limits. I can write this as the limit as h approaches 0 of sine x times the limit as h approaches 0 of cos h minus 1 over h plus the limit as h approaches 0 of cos x times the limit as h approaches 0 of sine h over h. Okay? Our calculations have brought us to 4 limits. This limit right here and this limit right here are pretty easy, okay? Because if h is approaching 0, nothing's happening to this. That would actually just equal sine x. And this, the limit as h approaches 0 of cos x, well, nothing's happening to the x. It's h that's approaching 0. So this thing would just be equal to cos x. So that would be cos x. This would be sine x. Now, through a little bit of work, okay, so that's what we just said here. The limit as h approaches 0 of sine x is sine x. And the limit as h approaches 0 of cos x is cos x. With some work, we can show that this is equal to 1 and this is equal to 0. Now, I'm not going to get into that a whole lot. If we made a little table of values, we could check that out. However, if that's a 1, so this would get replaced with a 1. And this would get replaced with a 0. So I end up with sine x times 0 plus cos x times, well, that's 0 plus cos x, which is just cos x. And that proves what we assumed would happen, or what we showed over here, that the derivative of sine x is, in fact, cosine x. Now, all that being said, here are the rules for differentiating your trig function. Okay, the derivative of sine u is equal to cosine u times du. The derivative of cosine u is equal to negative sine u times du. Now, that just means that you will, anytime you have a sine function, so like y equals sine x, its derivative, which we can call dy over dx, will equal cosine. In this case, my u value is x, and the derivative of u, the derivative of x with respect to x would just be 1. So it's cosine x times 1. So it's a chain rule. You always got to remember to multiply by the derivative of the argument, this u value. When that changes, as that gets more complicated, these get more complicated. Okay, the derivative of tangent u is secant squared u times du, and your other three are over here. These are your reciprocal trig ratios, cosecant, secant, and cotangent. Notice that all those, some of the little trick to remember, all the ones that start with c, they're negative. So cosine is a negative, cosecant is a negative, cotangent is a negative. But you will have to know these. And in this video, we're going to focus mainly on this one. Okay, and maybe a couple of these. Tomorrow I'll do one that involves the others. So, what I like to do, so I'm going to get out of the full screen mode. What I like to do is I like to write down my argument, my u value. So in this case, my u value is going to be 3x. The derivative of u is just the derivative of this. What's the derivative of 3x with respect to x? Well, that would be 3. Now, when I go to do the derivative, if I use Leibniz notation, dy over dx is going to equal. It's a sine function. Remember, the derivative of any sine function is cosine. So it's cosine, and I write my u value, which is 3x, times my du, which is 3. Okay? I'll do this in green, just kind of organize it a little bit. Now, how do I simplify that? dy over dx, oftentimes students write the following. Not true. Okay? The answer to that question in simplest form would be 3 times the cosine of 3x. That is the derivative of sine 3x. Okay? Do not multiply this constant by your argument, the thing in brackets or the thing that comes after your trig function. Example 2. My u value is x plus 2. The derivative of u, well, the derivative of 1x would be 1. The derivative of a constant 0 with respect to x, sorry, a constant 2 with respect to x would be 0. So 1 plus 0 is just 1. Remember, Newton notation, I can write y prime equals the derivative of sine u is cosine u times du. And that is just equal to the cosine of x plus 2. Third example, my u value is kx plus d. My du is, well, what's the derivative of 1x was 1. The derivative of 5x would be 5. The derivative of kx will be k. And the derivative of a constant 2 was 0. The derivative of a constant d would be 0. My derivative, back to Leibniz notation, same thing, dy over dx or y prime, pick your poison, whatever one you like. It's cosine u times du. My u value is kx plus d, and my derivative of that was k. When I go to write my final answer, it becomes k times the cosine of kx plus d. Okay? Try a couple more. They get a little trickier as we move along. In this case, my u value is x cubed. The derivative of u would be 3x squared. Y prime is going to equal cosine u times du. So it's the cosine of x cubed times 3x squared. Again, in simplest form, this becomes 3x squared times the cosine of x cubed. Okay, I'll just write the 3x squared in front. Now, this is a little different. Okay? Remember, with trig functions, that actually means the following. It means sine x times sine x times sine x. Okay? Or you can think of it like this. Sine x all to the power of 3. In order to do this, I would have to use a chain rule. Okay, so I'm just going to drag this, I'll drag this part down here. Y equals, not the derivative, y equals sine x cubed. To do the derivative of this, I would do a chain rule. The 3 would come down, rewrite my bracket, sine x to the power of 2, reduce the exponent by 1, but now we want to multiply by the derivative of what's inside the brackets. Okay, the derivative of sine x. So if I cover all of these things up and just focus on what's inside the bracket, the derivative of sine x would be cosine x times 1. I don't even need to write that 1. And if you're wondering where the 1's coming from, it's because my u value is x and my du is 1. So that's where that came from. That's where that came from. To clean this up, I will just go 3 times 1 is 3. And then I'll bring this exponent back here. 3 sine squared x cos x. Okay? So 3 times 1 is 3. The exponent went there. Sine squared x times cos x, you just stick them together. Same idea here. Now, I'm going to bring this one down underneath to give myself a little more room to work that out. Okay, so again, I'll rewrite this. So this one involves another chain rule. And you're always kind of using, you're using the chain rule when you're doing the derivatives of your trig function. But I would rewrite this as the following. Okay, ready to go? Y prime is going to equal 3. Rewrite the bracket. Sine x squared minus 1. Close the bracket to the power of 2. So the 3 went down in front. It's the derivative of the outer function. Reduce the exponent by 1 times the derivative of the inner. Well, this is the inner function, sine x squared minus 1. You can see that my u value is x squared minus 1, which means the derivative of that would be 2x, or 2x minus 0. So I have to do the derivative of sine u, which I know to be cosine u, times du. So cosine u is cosine x squared minus 1 times 2x. All right. 3 times 2x gives me 6x. This exponent's going to get ripped back in here. Sine squared x squared minus 1, followed by the cos x squared minus 1. And that is that. So there's where the 6x came from. This right here is just a simplified way of writing the following. Sine x squared minus 1 to the power of 2 means sine x squared minus 1 times sine x squared minus 1, which we write as sine squared x squared minus 1. All right. I think there's one more, and then you can go to work. This one here is a little different as it involves a function being multiplied by another function. In this one here, look, I'm going to have to do the derivative of cos x, so I'm going to have to know this rule right here. The derivative of cos x is negative sine u times du. And these all can be developed in a similar fashion to the way I showed you how to arrive at this. Okay? Okay. Remember the product rule. So this is a product of two functions. That means we have f prime g plus fg prime, or fg prime plus f prime g, however you want to write it. Okay? The derivative of the first times the second. So, if this happens to be the first, what would the derivative of x squared with respect to x be? That would be 2x times the second. So this is g. So I literally rewrite cosine x plus the first. So x squared times the derivative of the second. Now remember, my u value is going to equal x. My du, the derivative of x with respect to x, would just be 1. But now it's a cosine function. So that becomes negative sine u, or negative sine x, times 1. And I'll just clean it up from here. 2x dy over dx is going to equal 2x times the cosine of x. This would be a negative 1 times a positive 1 times a positive x squared, so I'll call it negative x squared. And then you've got your sine x here. Okay? You're multiplying here. X squared times negative sine x times 1 would give you negative x squared sine x. And from here, if you look at term 1 and term 2, you might notice that both terms have an x. This one's got a 2x to the first. This one's got a negative 1x squared. Well, there's nothing common to 2 and negative 1. But this one's got an x and this one's got an x squared. They both don't have a cos x, or they both don't have a sine x, so I can't take out a trig function. But I can take out an x, and I have to go with the lowest exponent. So this is an x to the first, this is an x squared. I'll go with an x to the first. If I divide term 1 by x, I get 2 cos x. All right? Now, it can't be like some people think, well, maybe you divide this would cancel that. Can't. You can't just have the word cosine or cosine on its own. It needs an argument. It needs to have some variable. They're called transcendental functions. Cosine on its own means nothing, or sine on its own means nothing. Negative x squared, if I take term 2, negative x squared sine x, and I divide it by x, that would leave a negative x sine x. And that is my answer. Now, you can do some homework. Okay? Page 313, 2 questions 1 and 3 from exercise 7.2.